Hello, my name is Nachum Danzig. I'm a lecturer at Jerusalem College of Technology. Today I want to talk about the Unix utilities called Sed and AWK, or AWK. So let's get started. Sed is a stream editor. It is a utility that parses and transforms text. It reads input line by line, applying the operation which has been specified via the command line, and outputs the line. Sed recognizes regular expressions. If you've already used regular expressions, you should know what that means. Let's do some examples. For example, let's say here we have a file. We have a file here. This is like an old password file. So it's got some names. Username is RELC. Notice that they're separated by colons. And there's several fields here separated by semicolons. This is RELC, RELD, Arkady. Those are the usernames, and here Arkady Wolf. And here's his home directory, user U37 stud Arkady, bin bash is his shell. That's a file. And that's just so you'll understand the examples. So now let's start with a simple substitution. So let's say we want to replace the word Ariel with the word Paul. So we're going to use S. Notice that this only replaces the first REL in each line. So for example, if I do like this, sed, stream editor, switch or substitute, REL for Paul in the file password. Password is the file that we just saw before. So now the output, now the file is not going to actually change. The file will remain as it was, but we'll get an output to the screen, which will be everywhere where it says Ariel, it'll say now Paul. So instead of Ariel C, it says Paul C. Notice that this Ariel didn't change, and this Ariel did. But on each line, it works line by line. So each time on each line that it sees the word Ariel, it replaces it with Paul, but not the second or third or fourth Ariel. To get it to do that, we use the G, or global substitution. So now we replace all the Ariel. So we do substitute Ariel with Paul globally. So Paul C, Paul Cheen, here Paul Daniels, etc. And here Paul C, Paul D. Everywhere where it said Ariel is now Paul. The third line didn't get affected because there's no Ariel there. So that's sed. Sed can be used with redirection because remember, it doesn't change the file. So we can create a file though. So we can do this switching of Ariel to Paul globally on the file name password, and then redirect it to a new file which we're creating on the fly here called new password. Later we can delete this password and rename new password to password, so we'll actually effectively replace it. But we can't do it in one shot. We have to do it in two steps. So here again, Ariel Paul is switched, and this is really the same thing. We're just taking. We put it in between parentheses. Like it's basically the same thing. We're saying go from the file, take the file password and pass it to the sed, and then the output pass it to the new password file. I prefer the first way of writing it, but some people write it the second way. Now, you can also print the matched character. So, for example, here's an example where I echo to the. I don't use a file. I just echo to the screen and to the standard out. 1, 2, 3, ABC. Now I put a pipe here, so now sed actually knows how to receive a standard input. So the pipe is going to convert this 1, 2, 3, ABC into a standard input. Sed will get it, and then it will replace any number that it sees with, and what is the plus there? This is a regular expression. So it means at least one time a number. So it could be 1, 2, 3, and it'll be greedy. It'll capture the largest possible capture, which is all of the 1, 2, 3, and then replace it with ampersand, which means whatever I found, which in this case is going to be 1, 2, 3, www, and then again ampersand 1, 2, 3. So you see that the output changes from 1, 2, 3 ABC to 1, 2, 3 on either side of a WW, and then the ABC doesn't get affected. So I've swapped something based on a regular expression, and then I put it back in along with something else. With in this case is WWW. That was useful for me in certain circumstances when I wanted to add something to something that was already there. This is like a way of adding, right? Because I find what I'm looking for, and then I put it back plus something else so I can add. Restricting printing with -n. So, and then forcing printing on the matched line with P. So, for example, I say cat, the password file. Okay, that's that 3-line file with RELs in it. Put it into sed. Don't print anything. -n. Don't print anything. And then it says switch REL with REL followed by a dot, which means another letter. So in this case, it'll be RELC or RELD with whatever you found. In this case, RELC or RELD, but twice. Ampersand, ampersand. And then do it global and then print. So wait, -n said don't print. So what does the -p say? It means print. So which is it? The answer is only print those things. As in general, don't print, but only print those things that you found a match for. So you see, I have these lines are actually wrapped around. This actually should be like one long line. RELC, 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 REL, REL, space. You see now the dot matched the space after REL. And then Chin, and then RELC, RELC. So that's the first one and the second one. But what about the third line, which, what was it? I don't remember now. It was Arkady Wolf. That doesn't get printed because I only printed the things that I found that I did a substitution on. So the P overrides the -n when there was an actual substitution performed. What about if I want to perform an operation on a particular line? So I can specify the line number to perform the operation on by specifying a range of 9 numbers. If I want a range, like from 100 to 110 or something, substitute the first REL followed by anything with an X, and what was matched, but only the second line, but only on the second line. So we're saying like this: sed to means on the second line, substitute REL with XXX, and then whatever you found, REL. But it's REL dot, so it's REL plus anything. But only do the first one. There's no G here. So that's why this REL Daniels doesn't get changed, but the username gets changed. Okay, so that's a way of restricting it to a line number. So here I wrote just 2. I could have written 2, 3, and then it would have been the second and third line. You can also drop lines from the output with a D to delete or drop any line that ends, for example, in this case, bash. So for what I do is like this. I notice there's no S here. I'm not substituting. I'm just saying it's a stream editor. It's not only a substitution. So I say a line that ends to the $sign there means end of line. So bash is the last thing on the line, which it isn't in this 2 cases, but I think in Arkady it was. So delete that line from the password file. So the output will be every line that doesn't have bash in it at the end. Bash AWK is the last line. So like if his name was REL bash, it would still print this line. It has to be over here where it says TC shell, TCSH. It has to say bash, and then it doesn't print. And that's in fact what we had for Arkady. He had notice his bin bash. It was ended bash. Okay. So that's the D. Anchoring characters. So, well, we have seen this in regular expressions. If you've seen regular expressions, we can use the anchor characters, which is beginning of the line is a caret and the end of the line is a $sign, as the sole characters in the source pattern to replace the target pattern at that location. For example, I can do switch the beginning of the line with 2. So it will add to the first character a prefix of 2. So notice the beginning of the line now will start beginning of line 2. I didn't really replace the beginning of the line. The line still has a beginning. If I would run it again on this output, a sed command, then it would again find it at the beginning of the line. It's not like I really replaced the beginning of the line, but I looked for the beginning of the line and then I put a 2 there. Well, there's still going to be a beginning of the line before the 2 now. Here, switch the end of the line with .00. So I have like a suffix 00. Again, I'm working on this file. Okay. And as we've seen, sed understands regular expressions, but here's another example. Replace any word starting AR, followed by any number of lowercase letters or colons, and the range is from 6 to the end of the line. So it was said from 6 till, now dollar here means not the end of the line, but the end of the file. From 6 to the end of the file is from 6 till the end, all the lines of the file after the 6th line, including the 6th line. Switch AR, and then followed by any character plus a or colon. This is an or, right? With, and then what's the star? Wait, what's the star here? The star means either none, right? 0 or more. With whatever you've found, with X's before and after it, and do it globally. Pity we don't have the output here. Combine operations with the -E flag. So delete. So here I can say sed -E and another -E, and I'm doing basically both of these things. So what does this mean? Delete any line ending no shell. So that means if its end is no shell, then do a D on it, delete. And then substitute away everything after the first colon on the remaining line. So I've already deleted those lines, but now if the line has gotten through that, because I didn't delete it, so then substitute. What does this mean? Everything after the first colon of the remaining lines. In other words, switch colon dot star. That means colon followed by any amount of stuff. So if you go back to our file, it's going to be this colon, any amount of stuff. It's going to go all the way to the end because the colon is going to match the star. There's the dot. The first colon, it's going to match. And then it's going to look for dot. Well, dot matches everything, including these colons. So I'm going to get all of the line except for what's before the first colon. Back to that. So delete everything and then replace it. I didn't really delete the line. I just replaced everything after the first colon with, and then I wrote nothing there. There's nothing between those two slashes, so I'm replacing with nothing. So it's like I removed it. So I'll end up basically just getting the usernames as long as they're not no shell. So in other words, basically if you think of what this means is, give me all the usernames in the password file for where the shell is not no shell. Because if the shell is no shell, then that user probably has been disabled. So it means basically give me all the enabled usernames from the password file. Now regex is greedy, which we saw actually in the previous example. Greedy means that it didn't it didn't give us, like, it didn't take the last colon to the end. It didn't just remove that. It removed as much as it could, which meant the first colon all the way to the end. That's called greedy. It tries to make the biggest match possible. But here's another example. Switch anything, either 0 or more times, followed by a colon, followed by again anything, followed by a colon on the password file. So we really wanted to replace, with an empty string, the first and second strings ending in a colon, as we wanted it to be like username, colon, password, colon. We wanted to replace that and get rid of that. But we didn't get that. That was not that was what we thought we were going to get when we tried to do this. But we didn't realize that regex is greedy. So what is it really going to do? You see what I'm saying? I wanted to just get the first thing until a colon, and then the second thing until a colon. But instead, the matching will go all the way to the last colon. We will get only the last string after the last colon. We'll go from anything which has a colon at least, and then until we get to a colon at the end. But it's not going to go past the last colon because it has to find that colon at the end. So it's going to switch everything in the line except for the last bit of the line, which is going to be, for example, sbin bash, or it could be sbin DC shell. We get only the last string after the last colon for every line. Understand? So again, if this is the file, it's gonna match. We thought we were just gonna match the RELD and then the RELD again, but it's gonna match everything until it gets to this last colon, because the dot. Because essentially what it did is it matched everything before this colon, and then the dot matched everything until it got to this colon over at the end. Go back and look at it, you'll see what I mean. It matched the first name until the colon, then dot everything until a colon. So we're going to get rid of pretty much everything from the line. All right, now we're on a different topic. AWK. I call it AWK. I think most people call it AWK. Because it's actually the initials of three people who wrote it. You can look up who they are. They're actually the pretty important people, especially the K. The truth is that people who wrote this are, or at least K, is one of the authors of the C language. So there's some similarity between AWK and C. So what is it? It is a pattern scanning and processing language. What does that mean? Well, we'll see. The format is AWK minus FC and then a pattern and an action. Well, we better see some examples. First, the minus FC uses the character C as the field separator, or FS sometimes. So whatever I write after the F is, we're calling it C here, but it's really the character that separates fields of a file. So for example, if I say, back to that same file that we were using, where there's colons separating the different fields. So if I say AWK minus F, use the colon as the field separator. Then if the third field is greater than 100, see, that's like C. If the third field, $3 means field number, because there's many fields in each line. If the third field is greater than 100, then print the third field. And then on which file? PWD. So what you're supposed to do is, this is the action. This is like the condition is here, and then the action is in the brackets. Inside these braces can be many lines, actually. And then the PW is the file, the password file, for example. So in this case, if we go, do I have the file again? Yeah, here. So let's say I have a file, for example, the third field. The third field is 100, 112, 139, 254. So if the third field is greater than 100, so that's not all of them. The first one was 100, right? 100 is not greater than 100. So it's going to print out Sally, Snoopy, and Linus. Let's see. Well, the whole line. Well, let's see. Let's go back. If it's greater than 100, print just the third field. So it's just going to print their number, actually. So it's not going to print Charlie. It's going to print 112. So uses as the field separator colon. We'll print the third field in each line in the following password file where that field is larger than the number 100, right? Well, that's what I explained. Here's another example. If the fifth field, well, if this is the third field, the fourth, the fifth field is Charlie Brown or Sally Klein or Snoopy Brown or Linus Smith. So if the fifth field, again, we're using the field separator as a colon. The fifth field is does not contain, this means does not contain, not tilde, does not contain, this is different from C++, does not contain the word Charlie, then print the third field. So again, it's going to print 112, 139, because those ones, the last three, do not contain Charlie over there, but the first one does. Okay. Contain versus is. Imagine that the number 4 contains the word Moshe. So if I say, or what I'm saying here is, if the fourth field contains the word Moshe, like we saw before, then print the first and the fourth field of my file. But if I want to say it is the field Moshe, in other words, it's not like Moshe Smith, but it's just Moshe. So it is Moshe. Then I have an exact match. Then I use a double equals. No, the double equals is like C++. Okay. Use functions and or regular expressions. So I can say print. Now, print was actually kind of like a function. This is do something, print. But here, length is really a function because look, it has parentheses. It really looks like a C++ function. So it's like this. Go through the file where the field separator is the colon again and print the length of the fifth field. So the fifth field is the name, so that's like Charlie Brown. So Charlie Brown, I guess, is 15 letters. So or 13, sorry, 13 letters. Print the length of it in letters of the file. So now what does this say? If the this prints the third field of any line that starts snow, or snow, or SNO. Because here I didn't say, here's my condition. In other words, the condition is not like the third field is. It's just saying if I have a regular expression match. If it starts off SNO, right, I'm just throwing in a regular expression match. Remember, this is the file. So wait, where's the file? Here's the file. SNO, the third line starts SNO. So I'm just, when you have these slashes, actually, it means, that's actually sometimes you'll see regular expressions written with slashes on the left and right. So that means this is a regular expression. So we're saying, as long as there's a regular expression match on the line for the following pattern, and the pattern starts with SNO. So then print the third field. awk has certain built-in variables which you should know about, and these are some of them. NF is the number of fields in a given row. So, like if every row is 7 fields, then NF will always be 7. But it could be that some have more colons than the other, or whatever field separator I'm using, determines how many fields there will be. And then it could be that the NF is different, but it'll give me the number of fields in it. That's very actually interesting because then, well, we're also going to see an example actually here. The print $NF, that's different from print NF. I'm talking about just NF on its own. NF on its own is the number of fields, so it'll be the number 7, if there's 7 there. NR is the ordinal current row number in the file. So in other words, first, second, third, fourth. So NR will be like 1, 2, 3. If I remember awk is going through the file line by line. So NR allows me to know which line I'm on. So for example, if I wanted to find the word Charlie Brown and I want to know where I found it, I could print NR. And then it would give me, not just that I found it, it'll tell me which line I found it on. Another interesting field is file name, is the name of the file being processed currently. When awk is run on multiple files, this is useful. In other words, I can give awk, here I just gave awk one file, so I kind of know that it's PW is the file. But I could theoretically give it a list of files, and then PW, another file, and then it would, if I found Charlie Brown, I could print the file name where I found it, and the row of that file that I found it in, and then I'd know where I found it. Otherwise, I would just print out the line, and I would have no idea which file it was from. So awk minus F, print. Now, what does this mean? I didn't say print NF. As I said print NF, it would print for every row 7, let's say, if that was the number of fields in every row. But if I say print $NF, it's like I wrote $7. Well, what's $7? That's the 7th field. But if a certain row had like 8 fields, then it would be $8. So it'll always be, if you think about it, the last field in the final field in the row. NF is the number of fields, then $NF is the final field in the row. So this will print the final field of every row. Braces. Now, there's actually basically just 3 sets of braces that you generally use. There's 3 sections of every awk. Up to now, we didn't use all those sections. We just used the middle section. But we saw that we had to, you put the action that we want to do, print, in a brace. We didn't just write print, we put it in the braces. So we also put it in single quotes. If you notice, there was a single quote and then a brace. Basically, we're saying inside the single quotes is the thing that we're going to do, and then if we immediately just do one set of braces, then that's the middle braces, which means do this on every line. But there's also a possibility of doing like this: begin, and then braces. And what that means is do this only before you start reading the file. Only one time before you start reading the file. So what I'm going to do here is I'm going to say print and then special variable file name. So before I start editing or working on the file here, notice it says P1 and P2, 2 files. I'm working on 2 files. So it'll print first the file name, and then I'm checking. This is my check. If the 5th field is equal to the value 10 exactly, then print what is $0. So if $1 is the first field, what's $0? It means the entire row. Print $0 means the entire row. And then end. So end is similar to begin. It means do this once, but when? Only when I finish processing all the rows. So every row is going to go through and print the row if its fifth field is 10. But at the end, it's going to print done. So minimum, I'm going to see, it could be that it'll never find a row like this. So minimum, I'm going to see file name done, file name done. But in between the file name and the word done, I might have rows of a file which meet this condition here. Notice that I didn't give a -f here. So what is the file separator? So the field separator, what separates fields here is default, which is white space. So it's going to be white space instead of a colon, for example. Colon was just what I was using. What does this do? So off here now I'm going back to the colon. Begin S0, S equals 0. So here what I'm doing is I'm not printing at the beginning. I'm setting a variable. Notice this looks a lot like C++. S equals 0. And then S plus equals 3. So what that means is S equals S, which originally was 0, plus the third field. If the third field is a number, so it's going to be like 7, then I'm going to add 7 to 0. And then I'll do this for every row because the begin is only on this first braces. The second braces is the middle behavior, which is on every row. And the third braces is at the end. At the end, I'm going to sum up, essentially, all of the third fields. And then I'm going to print the third, that sum, S, divided by NR. What was NR? NR is the number of rows. So presumably I went through 100 rows. So I'm going to now have 100 values I added to the S. And I'm going to divide by 100. So I'm going to get the average of the third field for this file. Whatever that means. But the point is, this is already like a program because I have, I initialize variables, I do my loop, on every row I do that, and then at the end I can print whatever I want to print. The AWK is very powerful. Another built-in, another built-in variable is called fs. We have seen that the field separator can be specified following the -f flag. It can also be specified using the built-in variable fs. So in other words, I did before where I did like -f colon or -f2 in this case. So the number 2 will be the field separator. But I can also just not specify it as a flag and just write awk begin, but then I can change it. What was it? It was potentially going to be a blank space. But now I can say fs equals, in my begin, I can say fs equals colon. So now I've defined it as a colon, sort of overwrote the white space, and then I can say if the fifth field does not contain brown, then print the number of fields. Print the last field in the file. Here I did where it's 2, but then I changed it to colon again. So this is kind of tricky. These two will actually print out the exact same thing. There's no difference. Because either way, whatever f was in the beginning, I changed it to a colon. So if it's really like C++, let's see a loop. So, for example, here, I can do begin, and then this is just one set of braces. So this will happen even before I hit a file. So if you notice, by the way, there is no file specified. awk, begin, and then do this, and then there's no file specified. Well, that's okay, because I'm actually not doing anything on the middle. There's no middle section here. There's just the begin section, which anyway processes before it hits the file. So it's going to do a loop. For I equals 1, as long as 1 is less than 5, I plus plus, or plus plus I. So I is going to be, when it equals 5, it's going to stop. Well, no. If it's less than 5, it's going to go. If it's even equal, so when it gets to be 6, it will stop. So it's going to print 6. Notice that this awk command has only a begin section, right? But loops can be run in any of the 3 sections of an awk command. So here's another example. If, here the field separator is colon, if the third field is greater than, well, what is this? Is this the beginning? No, this is the middle, because it doesn't have the word begin. So the middle, for every line, if the third field is greater than 100, then do the following. Now here I have nested braces, which are allowed. So there's really still three sets of braces, but this is all inside of the middle section of braces. So if it's greater than 100, then do the following. Set I to 0. Then while I is less than 2, so it's going to be 0 and 1, it's going to do 2 times. Print. Now this is not regular print. This is print F. If you know C programming, so print F exists in C programming and also here, and it's basically allows me to format how I print. So this means print a string, space, a decimal value, and then a return line. So what is the string? The string is going to be whatever immediately after. The first thing is going to be the first thing after the comma. So $5, the fifth field. So first print the fifth field, and then print, what's the next thing? I. And now the colon here, the semicolon, means that's the end of the print command. So what's this I++? That's a new line. So that's going to count. That's our counter. So our I is going to go. So what it's going to do is going to print twice. It's going to print the fifth line followed by a 0. Then the fifth line followed on a new line. The fifth line again. Sorry, not the fifth line. The fifth field. Again, the fifth field followed by a 1. Fifth field, remembers the name. So it's going to say Charlie Brown, 0. Charlie Brown, 1. Then it's going to say Snoopy Smith, or Snoopy Brown, whatever the next name was. Lucy Smith, 0. Lucy Smith, 1. And it's going to keep going. This has started to get long for writing on the command line, right? I'm writing a whole little program here on the command line. We can actually make it into files. We can open up a file in an editor like Pico or Vim or Emacs or VI, and we can name our file whatever we want. Let's call it awk1. Doesn't matter. Now we give it a shebang line where we tell it that the location of awk, and that we're running awk essentially. Otherwise, it would think it's a bash program. So I'm going to say bin awk -f, f because it's a file. And then I say begin. And the begin, I'm going to define the file separator as colon. And then in the middle section, I'm going to print the third field. Fine. So that's a very simple program. But the point is, I did it in a separate file. Then we can pass the file to the awk script in one of the two following ways. We can say, because we didn't, where's the file? We can then pass the file. Which file am I working on? So I have to give it the file. So I can either write, send the file to awk1. That's the name of this program. Or I can write cat it into the standard output, and then it'll be the standard input for awk1, and awk1 will know to read the standard input. Okay, so that's how I send the file to it, and that's how I write an awk in a separate file. So I mentioned already the shebang line, but I mentioned again here, the shebang line just tells you where to look for the AWK function. You have to know where it is. You can do a where is or a which to find this location. If you would be writing a bash script, you would write bin bash. That's where bash is located usually. In bash, you don't necessarily have to have it because it'll by default run bash, assuming your shell that you've logged into is a bash shell. But you probably didn't log into an AWK shell, so you have to specify it. Here's an awk4. This is our last example of awk. An awk4 example. So, for example, I do a begin again, and I say that the field separator is a colon. And then I say, if the third field is equal to exactly 101, then for I equals 0, as long as I is less than 2, I plus plus. So I'm doing a loop 2 times, print, and now I didn't do print F, I just did regular print. Print the fifth field, and then the number I. And then when I want to run it, I'll do the same thing. I'll pass. That's the end of the program after this brace. When I want to run it, I'll pass PW into AWK, and it'll print me the only those lines in the file where the third field is 101. And I think we have some like that. That would be 101 maybe that's, wait, the third field, 1, 2, 3. Here, No, I don't have a 101 in the third field. 1, 2, 3. The fourth field here is 101. The fourth field here, actually for all of them, the fourth field is 101. But for none of them is the first field. So in my case, sorry, the third field is never going to be 101, so it's not going to print anything. Okay, very good. Good luck with your AWK programs. I hope this was helpful. I'll see you in the next video.